let's take a look at an example of implicit differentiation when you cannot separate x and y easily. So given this equation, given this relationship, we want to find the derivative dy over dx. So in order to find that, we need to take the derivative with respect to x on both sides of the equation. So when we encounter the first term right here, we see it's a product, x to the fifth power times y squared. So we need to use the product rule. Just go through it as usual, one by one. So what is the derivative as x to the fifth power? Is 5x to the fourth power times the second term, so it's y squared, plus x to the fifth power times the derivative of y squared. So now you need to be careful. It is 2y, but then it is a function of x, so you get dy over dx because of the chain rule, okay? Then you continue, subtract another product right here, 5x squared times y. So 5x squared derivative is 10x times y, okay? Then again, minus 5x squared times derivative of y is just 1 times dy over dx. And then you continue, right? Subtract derivative of 6x is 6 equal derivative of negative 12, 0. So now you solve for dy over dx. So you combine like term. So what are the like term here? This with dy over dx. So you get x to the fifth power, so 2x to the fifth power y, minus 5x squared, and you factor out the dy over dx in the back. Then equal, you bring everything else that doesn't involve dy over dx to the other side of the equation. So that will equal 10xy plus 6 minus 5x to the fourth power y squared. Then you solve for dy over dx by dividing both sides by its coefficient. So 10xy plus 6 minus 5x fourth y2 divided by 2x fifth power y minus 5x squared, and that's it.